We've talked about how to find the lateral area, which is all of the sides except the bases, and the surface area, which is the area of all of the sides added together. And today we're going to talk about volume. So we've talked about basically like wrapping a figure. Today we're going to talk about filling the figure. So we want to know, like, what's the volume? So as a solid, what would it be? How much space would it take up altogether? Not just how much paper would it take to wrap it, but how much water would it hold? That's what we're looking at today. So the volume of a prism, we're going to look at prisms and cylinders because they have very similar equations. So the volume of a prism is capital BH, where remember that capital B is the area of the base. So that depends on what the base is. Is it a rectangle? Is it a triangle? Is it a pentagon? Whatever it is. And then H is the distance between the bases, just like it was before. So the H hasn't changed, and we still need to find the base, just like we always did. So if you look at number 1, we have a rectangular prism. Okay, we can use whichever base we want, but we tend to use the one that it's sitting on, particularly for a rectangular prism. So we need the area of the base. So the area of the base, the shape of the base is a rectangle. So the area of the base would be the base of the rectangle times the height of the rectangle. So it'd be 6 times 2, which is 12. So the area of the base is 12. The height, the distance between the two bases, is 4. Because our bases have to be congruent and parallel. So here, this is my other base. So we have the area of one base times the height. So my volume would be the area of the base times the height, or 12 times 4, which would be 48. And volume is in units cubed, meters times meters times meters. Okay, number 2, we want the volume of this trapezoidal prism. Remember, we have to find the base. So the base is the ones that are congruent and parallel, not just congruent, but congruent and parallel. So there's my base. So remember, we found the surface area of this the other day. So we need to find the area of the base first. Okay, so the area of my trapezoid. So just ignore the whole rest of the picture and just look at the yellow trapezoid. So the area of a trapezoid is 1/2 base 1 plus base 2 times the height of the trapezoid. So if you take 18 plus 23, multiply that by 12, and divide that by 2, be careful. If you're going to do all of that in one step, you need to use parentheses. You get that the area of your base is 246. So the area of my base is 246, and then the height is the distance between the bases. So the distance between the bases would be 15. So it would be 246 times 15, and that's where you get the volume of this shape would be 3,690 cubic feet cubed. Okay, so again, we always have to find the area of our base. So I want the volume. We need to decide which one the base is. Remember, the bases are parallel and congruent. So my base is going to be my triangle. So here's my base. So let's just isolate it and just look at our base. So the area of a triangle is base times height divided by 2. So just look at your triangle, right? So we have the area of the triangle is half the base times the height. And so the area of the base would be 30. Okay, then we need the height. Well, that's the height of the figure, the distance between the bases. That's the tricky part. We want to just use 5 times 12 times 5, but then I never left the triangle. I have to push back into the shape so that it can hold something. Okay, imagine this is one of those collapsible cups. You got to push the bottom out of that collapsible cup so that you can fill it up. So then my volume would be the area of the base times the height of the entire shape, and you get 420 meters cubed. Now, the volume of a rectangular prism is 655.2 feet cubed. If the base of the prism is 9 feet by 5.2 feet, find the height of the prism. All right, so let's write this down. So the volume is equal to the area of the base times the height. Well, it says that it's a rectangular prism and the base is 9 by 5.2. So let's come over here and let's find the area of the base. So the area of the base would be 5.2 times 9. So 5.2 times 9 is 46.8. So the volume, which was 655.2, is equal to the area of the base, 46.8, times the height. Rectangular prisms are easy, right? It's length times width times height, but because now we're not just dealing with rectangular bases, we can't use length times width times height any longer. We have to be able to account for other shaped bases like triangles and trapezoids, which is why we don't use length times width times height anymore. But the area of the base for a rectangular prism is length times width, and so we can still use that when it is a rectangular prism. So now we just divide both sides by 46.8. Those cancel out, so 655 divided by 46.8, you have a height of 14 feet. Now, the formula for the area, or for the volume of a cylinder, is very, very similar, and in fact, it is identical to the volume of a prism. Okay, so the volume of a cylinder is the area of the base times the height. Now, remember that the base of a cylinder is a circle. And so what ends up happening is it's the area of the base, your big B, the area of the base is a circle, so it's pi r squared times the height, which is the distance between the two circles. So the volume of this cylinder, if I find the area of the base, is pi r squared. So r is 3, so pi r squared is 9 pi. Now I don't want to leave it, I don't want to write all those decimals, so I'm just really going to be lazy for just a second. So volume is equal to the area of the base, 9 pi, times the height, right? Here's the height, the distance between the two circles. So that's 6. So you can type this all in, and you can do 9 times pi times 6, and you can get 54 pi, or you can approximately get 169.6 meters cubed. Okay, so Madison made a cylindrical vase for her art project. I like to go ahead and always draw a picture if I can. If the vase has a volume of 454 cubic centimeters and a diameter of 8, what is the height of the vase? All right, so let's go back and look. So volume is the area of the base times the height. Remember the area of the base. So let's go get the area of the base. The area of the base is a circle. So pi times radius. Well, the diameter is 8, so the radius has to be 4. So I'm going to be lazy again. I'm just going to write 16 pi instead of writing all of those decimals. So the volume is 454. That equals to the area of the base times the height. Now, you can handle this one of two ways. You can do 16 pi, and you can get that 454 is equal to 50.27 H, and then divide both sides by 50.27. So 454 divided by 50.27. And you get a height of 9.03 or 9. Or if you want to do it all in one step, you could also do, you just got to be really careful here, you could also just divide both sides by 16 pi. Now when you type that in your calculator, you either got to divide by 16 and then divide by pi, or you divide by 16 pi with parentheses. Either way, you're going to get a height of 9. Okay? You can always go back. You don't have to use BH. You can always use pi r squared h if you want to, and then just plug it straight into the formula so that you don't have to come over here and find the base and then go plug it into the formula. You could have just done 454 is equal to pi r squared h, just like that, and then you could have solved it the same way. Okay? So ice cream is sold in two different containers. The first container is a cylinder with a radius of 4.5 inches and a height of 11 inches. The other container is a rectangular prism with a rectangular base with a length of 8 and a width of 5 and a height of 9. Which best describes the relationship between the two containers? Well, the relationship between the two containers, they're all about volume. So I'm all asking about volume, so let's check our volumes. So volume is equal to pi, area of the base, pi r squared times h. So if we type that in, we get pi times 4.5 squared times 11, and we get that the volume is 699.8. And then we've got volume is the area of the base, which was 8 by 5, times the height, or length times width times height is what you're used to seeing. Length times width times height. So 40 times 9 is 360. So it doesn't take up, well, it takes about 9 inches, right, across, 9 inches across for the cylinder versus 8 inches across, but it's 2 inches taller, but it holds close to double the amount. So obviously then the cylinder has the greater volume. As long as you have those measurements, you can determine those. So the equations for prisms and cylinders are exact, right? They're the same thing, but you can go ahead and replace the circle, because for a cylinder the base is always going to be a circle, where with a prism the base could change. It could be a trapezoid, it could be a triangle. So that's why we need to use the area of the base for a prism, but the area of the base for a cylinder is a circle, so we can just go ahead and use pi r squared times the height, which is the distance between the two bases.